In this video, we're going to tackle about the areas by integration. The key topics in this lesson are: number one is the area under a curve, and number two is the area between curves defined by two given functions. So let's move on to the first part of the lesson. The first part is discussing about the four cases of area under a curve. The first two cases are the area under a curve where region bounded by the given function, vertical lines, and the x-axis. In these cases, you'll notice that the boundaries of the vertical lines are the same. The only difference is that the first case is in the quadrant 1 and the other one is in quadrant 4. If f of x is a continuous and non-negative function of x on the closed interval a, b, then the area of the region bounded by the graph of f, the x-axis, and the vertical lines is x is equals to a and x is equals to b, and is given by the area is equals to the integral of f of x times dx, having a limit of a to b. So next is the third and fourth case. These are the area under a curve where given function region bounded by the horizontal lines and the y-axis. If f of y is a continuous and non-negative function of y on the closed interval c and d, then the area of the region bounded by the graph of f, the y-axis, and the vertical lines y is equals to c and y is equals to d. In certain problems, it is easier to rewrite the function in terms of y and calculate the area using horizontal elements. In this case, the formula for the area would be area is equals to the integral of g of y times dy, having a limit of c to d. Let's start the first example for area under a curve. Find the area bounded by y is equals to x squared plus 2x plus 1, x is equals to 1, and x is equals to 5. So in order for you to solve this in the right way, follow these steps. When calculating the area under a curve f of x, follow the steps below. So number 1 is to sketch the area. Number 2 is to determine the boundaries. Number 3 is to set up the definite integral. And number 4, lastly, is to integrate it. Let's go back to our first example. We need to find the vertices of the equation to be able to sketch the area. You'll notice that this example falls to our case 1 or 2, wherein area under a curve region bounded by the given function, vertical lines, and the x-axis. Next step is to determine the boundaries. The boundaries are already given. X is equals to 1 and x is equals to 5. Next step is to set up the definite integral, wherein we have here a is equal to the integral of x squared plus 2x plus 1, having a limit of 1 to 5. And we are ready to integrate it. So the integral of x squared plus 2x plus 1 is x cubed over 3 plus 2x squared over 2 plus x. After that, substitute the x values, and then we will have an answer of 208 over 3 square units. Let's move on to the second example. Find the area bounded by the function y is equals to sine x from x is equals to 0 to x is equals to pi over 2. Again, the first step is to sketch a graph. Automatically, a given having pi over 2 will be having a 90-degree graph like you can see on the video. Next step is to determine the boundaries or interval. The boundaries are already given. X is equal to 0 and x is equal to pi over 2. Next is to set up the definite integral. A is equals to the integral of sine x dx having a limit of 0 to pi over 2. And we are ready to integrate it. The integral of sine x dx is negative cosine x. After that, substitute the x values where x is equal to 0 and x is equal to pi over 2. And our answer is 1 square unit. Let's move on to the last example for area under the curve. Find the area bounded by the function y is equals to e raised to x, where x is equals to 3. Again, the first step is to sketch a graph. Automatically, a given having e raised to x will be having a graph like you can see on the video. Next step is to determine the boundaries or interval. The boundaries are already given. X is equal to 0 and x is equals to 3. Next is to set up the definite integral. A is equals to the integral of e raised to x dx having a limit of 0 to 3. And we are ready to integrate it. The integral of e raised to x is e raised to x. And we are ready to substitute the x values. E raised to 3 minus e raised to 0, e raised to 3 minus 1, and then we will have an answer of 19.09 square units. So let's move on to the second part of our lesson. So the last part of the lesson is discussing about the area between two curves. This can be considered as a more general approach to finding areas. Thus, each of the previous examples could have been solved using such an approach by considering the x and y axes as functions with equations y is equal to 0 and x is equal to 0 respectively. Many areas can be viewed as being bounded by two or more curves. When area is enclosed by just two curves, it can be calculated using vertical elements by subtracting the lower function from the upper function and evaluating the integral. Analogously, to calculate the area between two curves using horizontal elements, subtract the left function from the right function. As always, a sketch of the graph can be a very important tool in determining the precise setup of the integral. If you subtract in the wrong order, your result will be negative. The mistake can be avoided by taking the absolute value of the difference of the functions. So, as you can see in the video, here are the universal formula for finding the area between two curves. So in using the vertical elements, the area is equals to the integral of y sub upper limit minus y sub lower limit times dx, having a limit of a to b. Next is where y upper limit and y lower limit are functions of x. Next is for the using the horizontal elements. wherein the area is equals to the integral of x r minus xl times gy. It pertains to the x sub right minus x sub left, where x r and xl are functions of y. Here is an example for area between two curves. Find the area bounded by y is equals to x squared and x is equals to y squared, where x is equals to 0 and x is equals to 1. Again, as always, the first step is to sketch the graph. Next step is to determine the boundaries or interval. It is already given where x is equals to 0 and x is equals to 1. Here you can see in the video the equation x is equals to y squared has been given by square root of x because we eliminate the squared in y. And next is to set up the definite integral wherein a is equals to square root of x minus x squared dx having a limit of 0 to 1. So the integral of substitute the x values, and then the integral of square root of x minus x squared is 2x raised to 3 halves over 3 minus x cubed minus over 3, and then substitute the x values. So the answer is 1/3 square units. So that's the end of the lecture. I hope you learned a lot. Thank you.